So we'll start off with polynomials in one variable. They're usually in the form of ax to the power of n, where n is a non-negative integer and a is a real number called coefficient of the term. The degree of the polynomial is the largest exponent. So the largest exponent in the first one is 12. The next largest exponent for the second equation is 4. The next one is 23. After that, it's 1, because we've seen nothing above the x, and there's no variables, so this one is 0, the last one. We have some examples of non-polynomials. The first one is not a polynomial because it has a negative exponent. Polynomial exponents are positive. The next one has a rational root. It can be set to 5x to the power of 1 over 2. So polynomials must have a non-negative integer, which we see in the next one has a negative integer. So that's not polynomial either. Also, remember, radicals and fractions are allowed in polynomials. They just can't have variables. So we'll do polynomials with 2 variables. To find the degree, we basically just add the highest degree for x and the highest degree for y if they're together as the same term. So we'll end up with something like this. That's because polynomials in 2 variables consist of terms in the form of ax to the power of n times y to the power of m. The degree is the sum of the exponents in each term. So to find monomials, examples would be 5x would be a monomial. A binomial would be considered something like x plus 5. Another example of a monomial would be 8x squared. Another example of a binomial would be x squared minus 3x. And an example of a trinomial would be something like x squared plus 5x minus 8. This is a very common thing, you'll see. Next, let's consider what's known as the distributive law. If we have a times b plus c, we basically just multiply everything by a. So we have ab plus ac. Now we're going to try adding and subtracting polynomials. First, with the polynomial, if we're going to add a polynomial, we could just do a very quick way where we just add and subtract like terms right off the bat. So we just 13x squared plus minus 10x. Then we could do plus x minus 9x, and we just add those like terms, minus 45 plus 4. But here we're going to really show what's going to happen and how we're going to really break this down. So we're going to start off by putting brackets around each expression. And that's a 4. So we're going to just put the like terms together. So 6x plus 5, 6x to the power of 5 doesn't have a like term, so we'll just leave it by itself. Then we're going to add it to minus 10 plus 13, because minus 10 and 13 have the variable x squared. And then we're going to have both of those multiplied by x squared. Referring back to the distributive law. And now the next bracket is going to have 1 minus 9, because x and minus 9 have the same variable, which is x. And then we're going to have 45 minus 45 plus 4, because those coefficients have no variable. Then we're simply going to solve from there. So minus 10 plus 13 is 3. Then we multiply that by x squared. And 1 minus 8 is negative 8. Then we multiply that by x. And minus 45 plus 4 is negative 41. Sorry, I meant 1 minus 9 times x equals minus 8x. now that we basically have some of the basics down, we can just try to do this the quick way. So we'll set this up the correct way because we're subtracting 5x to the 3 minus 9x squared plus x minus 3 from x squared plus x plus 1. So the reason why we're putting parentheses around one of the expressions is because we're subtracting the whole thing from the other one. And when we subtract, the signs change. So we're going to have x squared plus x plus 1. And we're going to subtract that from 5x to the 3 minus 9x squared turned into a positive 9x squared, and plus x turns into a minus x, and minus 3 turned into a plus 3. Then we're going to add the like terms together. So 5x3, there's no like term, so we'll keep that by itself. To get 9x squared plus x squared is 10x squared, because we're basically adding 9 plus 1. And then we're at this point just adding 1 plus 3, which is 4. Let's try solving these using the distributive law. So remember, when variables multiply by each other, their exponents add. That's why we have 4x to the power of 4 minus 24x to the power of 3 plus 8x squared. Now for the next one, we use what's called the FOIL method. So first we have 3x times x, then we're going to multiply 5, or 3x times 10, times minus 10, then we're going to have 5 times x, then we're going to have 5 times minus 10. So everything in one bracket multiplies by the other bracket, the other parentheses. And then from that point we just add like terms. 3x squared has no like term. Minus 30x adds to plus 5x, and minus 50 stays by itself. We're going to use the FOIL method once again. So we'll have 4x squared times 6. Then we'll have 4x squared times minus 3x. Remember, the exponents for variables add together. Then we're going to have x minus x times 6, which is minus 6x. Then we're going to have minus x times minus 3x. And then we're going to add like terms. So 24x squared has a like term to plus 3x and the reason why we put minus 12x3 is just because it has the highest degree, so we'll put it at the start. And FOIL method once again. 3x times x, x squared. 3x times minus 2y. Although they have different variables, it'll end up looking like this, minus 6xy. And again, 7y times x, and 7y times minus 2y. And then we just add like terms. 3x squared doesn't have a like term. Minus 6xy would actually add to plus 7xy because they have the same variables. And then minus 14y squared by itself. And again, FOIL method. This time we're going to have 2x times x squared, then we're going to have 2x times minus x, then we're going to have 2x times plus 1, then we're going to go to the next number in the first bracket, which is 3 times 3x squared, then we're going to have 3 times minus x, 3 times 1. This is very important to understand. Feel free to pause or slow down the video if you feel as though I'm going too quick. Then we add like terms. And we're left with this. So here are some special forms that are very good to remember. They just make things so much quicker when you're doing the FOIL method. Remembering these it's very, very useful. You can get things done very quickly. So it's probably important to write these down, remember them, and we'll do a couple examples of where we actually use these special forms. So if we have 3x, basically these equations, the only difference between the two brackets is the plus and a negative sign. If we see something like this, when there's a plus and a minus sign that's different, and they have the same numbers, we can just do this. We can just do 3 times 3, 9x squared, and we can do 5 times 5, minus 25. You can do it the long FOIL method way. You'll find out that you'll get the exact same answer. For this one, we think of it as 2x squared, and then we think of the next number as 2 times 6 times 2, because the exponent over the parentheses is 2. And then we just do 6 squared, which is 36. And for this one, we do 1 squared, and then we do 1 times minus 7 times 2, because the exponent is 2 again. And then we just do minus 7 x squared, which is 49x squared. And at this point, we are going to use the same method as we did for the last two, except once we get an answer, then all we're going to do is multiply it by 4. You can do this with the distributive law, but I like these forms because they're just so much quicker.